Is that you? Screen. Okay. Share screen. Start the broadcast. And then real quick, right here. And just close all the tabs. That's fine. This one. I just realized I don't think I made the one for today. I meant to do it in advance and I just did not get a chance. I've been kind of stuck all day. So give me a moment to go ahead and make a review. I know we can do like 150. Yeah, I just honestly I kind of want to go ahead and do it for chapters 3 and 4 as well. So just give me like a few minutes to like create these assignments just for a practice. Let me see. I don't think there's anything already there as far as a review. Let me go to manage. And it just give me like 10 minutes or so. Let me see. Yeah. So let me see. Chapter 2. Practice not graded. Edit. This is going to be for practice. No grade, not graded. Copy. Save and assign. So yeah, just give me a moment. I want to go ahead and make a review for the remaining chapters, because if I don't do it now, I'll get distracted and it'll be next week, and I'll be like, oh, let me do that. So just give me a few minutes, and we'll get the party started. I'll go ahead and pull some questions for chapter 2. So what I'll do is hop to chapter 2. Let me see. I think we went through all 6. Siri, what's 150 divided by 6?
150 divided by 6 is
25. Okay. 25. 1, 2, 3, 4, 6, 7, 8, 9. Nope. 1, 2, 3, 4. Do we even have 26? I don't think we have 25. Let me just get all of these. Okay. 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10. I don't think we have that many in this one either. Matter of fact, it's only 105. I can just do all of them. That's cool. That makes it easy. Add. Nice. Okay. Easy peasy. All right. Save and assign. Let's see. Oh, wait a minute. That's fine. Now there is something there. Practice not graded. Okay, I see chapters 1 and 2. Do I see 3 and 4? There should be something that says practice not graded. I'm not seeing it. So, okay. Let me go ahead and do chapters 3 and 4. I did chapter 2. Just give me a moment and we'll get the party started. Create homework. And this will be chapter 3. Paste. Chapter 3. Copy. Okay. Media. How many questions we got? Let's go to chapter 3 real quick. Did we do all of these sections? I think we did all except section 9. That's fine. How many? 2? Let me see if I do all of them. I know it's going to cut it short some. That's fine. Oh, boo. Okay. Let me try to knock off 3-9 because I don't think we did 3-9. That looks like. And then let me try to knock off a few more. 3-8. This. How many questions do I have selected? No. Sorry. And these assignments that I'm creating right now are just for practice. Once I get them going, let's keep going. Knock off a few more. About 70. I need to knock off like 75 of them. Be nice if I knew how many I selected. We gotta be close. Let's do another pass. Come on, guys. I know this is close. Let's try this. There we go. 145. Okay, that's good. Okay, so that's chapter 3. We'll work on this one next week. And let me go ahead and do one more, and then we'll get started. Save and assign. Come on. Okay. Let me see. Let's do one more for chapter 4. Create homework. What time is it? Okay. Let's paste. This is chapter 4. Select the media. If I go to chapter 4, how many sections? Numerical integration. So we didn't do section 4.7. That's fine. 213. So I need to knock off 60, about 63 of them. I'm gonna do all. Now I know that last section we didn't do. You're not responsible for. So I can remove all of these. 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 12, 13, 13, 14, 15, 16, 17, 18. So that's 18. We need like 40, 42 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Nope. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 7, 38, 39, 40. Let's do like 3 more. 1, 2, 3. Okay, let's knock off like 2 more. 1, 2. How far off are we? 2. Cool. 5. Okay. We weren't that far off. Okay. Okay. Let me save this. This will serve as a review. Save and assign. And let me make sure I got everybody in today. Let's just go like this. Lemons in Maine, lemons in Maine. Let's see, JK. Okay, nice. All right. All right. So let's go ahead and pull up the review for today. So, painstakingly, we went on and made a review for each chapter. We already did chapter 1 review last time. So these are just for practice, like if you just need some additional practice. Today we're gonna focus on chapter 2 with whatever time we have remaining. So we're kind of in the home stretch. We've had 2 exams, right? You still have access to them. If you've made less than a 95%, you're welcome to redo them and improve your score. The system is only going to show your highest score. Remember, we get unlimited attempts. The system is set to take a higher score, and there's only a 5% late penalty. So all the way until the hard deadline, you can still earn up to 95% on any assignment, including exams. So today is what, Wednesday? We'll review chapter 2 this week. Next week on Monday is chapter 3. I think we meet next Wednesday. That'll be the last class. A week from today, we'll review chapter 4. And then the final exam, let me see if I see it. It becomes available. It should be a Sunday, May 5th at 11:11 a.m. And then it's due Friday, May 10th at 11:59 p.m. That Friday, May 10th at 11:59 p.m., that's the hard deadline for all assignments, okay? If you have questions, feel free to unmute yourself to get my attention and we can talk about it. But for today, we're just going to let's go ahead and open up chapter 2. Let me change my view. Yeah, I almost didn't make it to class today. I've been stuck in the mud literally all day. Like I got stuck around 10 a.m. and we got somebody that finally have the right tools to pull us out. I got out about an hour ago. So I've been stuck in the mud literally all day. And I was, like I said, I was almost late to class, didn't make it, but they got us out. I was like, cool, I can do what I need to do. All right. So again, this is just for practice. If it's just there, just a little. There are 105 questions in this one. So let me see. Give me a random number between 1 and 105. 26. Okay, let's start with question 26. Okay. So question 26 it should come from chapter 2. Let's see, it comes from section 2.2, question number 3, and we're asked to differentiate, right? We have 7e to the power of 4x. So remember, e is a special case, right? The derivative of e is itself times the derivative of the power, right? So let's see if that works. So it's its own derivative, so we're going to say 7e to the power of 4x. And then we're going to say times the derivative of the power is just going to be 4 in this case, right? So we say that result times 4. So that's going to make this a 28, and we should be Gucci. Again, if anything's not clear there, just let me know, and I can recap and go back. Let's do another one. Let's go to question number 10. So I'm liking my little random number, my RNG, because before, I used to feel weird, but now I just got a little system going. So given that the natural log of 4 is this, natural log of 4 is this, natural log of 7 is this, find the value of the following log without using a calculator. So we got the natural log of 112, right? Siri, what's 112 divided by 7?
112 divided by 7 is 16.
So 112 is what? 4 times 4 times 7, right? So I can take some notes here. So we can use the product rule for logs, right? We can break this apart. So this is the same as the natural log of 4 times 4 times 7, right? 16 times 7. So then that's going to be the same as, now we break it up into 3 separate terms. The natural log of 4 plus the natural log of 4 plus the natural log of 7, right? So all we do is say the 2 of the first one plus 1 of the second one, and we're Gucci, right? I'm going to use my calculator, but I feel like the main thing is that we know that we can split this up and use the product rule. The log of the product is the same as the sum of the logs, right? Siri, what's 2 times 1.3863 to plus 1.9459.
I found some
I totally stammered over that. I got a calculator here. Matter of fact, I'll just go ahead and pull up the calculator here. I was avoiding it. Guess I can put it here. That's fine. Calculator, start key. Start key. Okay, cool. You're looking good. All right, ready to rock and roll. Let me give my device some juice because they're looking like it's getting low. Okay, so 2 of the first one plus 1 of the second one, right? So we're gonna say, nope, not there. 2. Let's see, replicate. Darn, let me get this over here. Nope, you're still not working. Come on. Maybe if I switch this around like this, maybe that'll do it. Nope. How do I get the cursor over here? Okay, let's see. Try one other thing. Put it like this. Sometimes this will do it. There we go. That did it. Okay. So to replicate 1.386, 3863, addition, I can hit this. Okay. 9459. 9459. Okay. Then 7185. 7185. Again, if anything isn't clear, feel free to unmute yourself to get my attention, or you can type it in the chat. I do monitor the chat. Let me kind of check real quick. I think you guys are okay. Mr. Jackson, he's almost late. It's okay. Better late than never, though. All right. Let's do another number. Let's go to question 4. Right here. So question 4, this comes from section 2.1, question 11. It says, an initial investment amount P, an annual interest rate R, and a time T are given. Find the future value of the investment when it's compounded annually, monthly, daily, continuously, and then find the doubling time, okay, for the given interest rate. All right. So I think what I'm going to do here, I think I'm going to make a formula where our compounding is our variable, right? That's the only thing that's going to change. So if we're doing compound interest is what? The future amount equals P times 1 plus R over N to the power of N times T, okay? So that's compound interest, okay? So if we're gonna make our formula, what's our principal? We're starting with 75,000. Nope. I have to do that again, seriously. What if I go here? Cancel. Nope. Okay.
Is there a way you show it on like a?
Where's in my hand? Nope. Okay, now let's see. Say it again.
Is there a way you
So
can put
let me
it like
see.
step by step on paper?
I mean, I can, yeah, sure. Like all it is the formula here, right? This formula, and they gave us the parts, right? So if you screenshot that formula, they gave us the principal. So the principal P is 75,000. R is 2.3%, so we have to convert that to a decimal. T is 5 for 5 years, and then N is going to change with each part. So I'm basically plugging in those parts that's in the upper left-hand corner into that formula. The only thing that's going to be changing is N, right? So if you screenshot this, I think you can you can kind of get it from there. And so that's the only reason I'm doing it this way, because it's really just plugging into the formula. Once you have the right formula, 75,000. Let me kind of work like this. Hopefully it doesn't disrupt it, because it's being a little bit temperamental. Let's see. Parentheses. Yeah, it is. I don't know why it behaves that way. All right, I'll just do this. So we got the 75. They gave us P, parentheses, 1 plus our rate. So 2.3% is going to be 0.023 as a decimal. Now our N is going to be changing, so I'm going to say divided by X. Okay. Then I'm going to say to the power of 5, because it's 5 years, so I'm going to say 5 times X, because we're just replacing N with X. So that way now we can only change our N and get the answer for each one, right? So then now I want to evaluate that function. The part A is if it's compounded annually, that means our N is what? 1, right? So if we let N be 1, that should be the result after 5 years. Okay. So now I'm just going to submit that to the nearest cent. 84.30.98. 84.30 and 98 cents. Okay. And then now the next one is monthly, right? So now our N goes from 1 to 12. So I want that same formula. Instead of N being 1, or instead of X being 1, I let it, now it's 12 because we want monthly, and it spits out the answer. Right? Because again, the only thing that's changing is N, so I made that my variable. 84.131, 84.131, and 25 cents. Okay. Daily is 365, so now we let N be 365, and that should be the answer. 84.140 and 20 cents. Continuously, so now we have to use a different formula. Continuous is PERT, PE to the RT. So the principal is 75,000 times E. The rate is 0.023, and the time is 5 years. So we're using PERT. A equals PE to the RT, PERT. Okay. So then we get 84.140 and 51 cents. Okay, so that for D, we did use a different formula. Now it says we're asking us to find the doubling time. Now that one I think I will write out, because that one takes a little bit out. So let me see what I'll do for this one. I'll open up my notes. Okay. And so again, here it is. This comes from section 2.1, question 11. This is part E, the doubling time. Right. The principal that's given is 75,000. The rate is 2.3%, and the time is 5 years. We want the doubling time, right? So we wanted to go from P and finish with 2P, right? So let me see if we're doing, I think we use PERT for that one. Okay. So then PE to the RT. And if we're starting with P, we want to finish with 2P. I think this will get it, right? So we can divide both sides by P and they're going to cancel each other out, right? That's okay. So this is going to cancel that. So then now we're going to have e to the RT equals 2, we can take the natural log on both sides. That allows this to come out, and this is gone. Okay. So now at this point we have RT equals the natural log of 2. So we want the doubling time, so we're really solving for t. Ultimately, t is going to be the natural log of 2 divided by r. So the doubling time is going to be the natural log of 2 divided by r. And then from there, we use our calculator. Okay. So, like that, perf. Right, okay. So then we'll just do the natural log of 2 divided by 0.023. Okay. So let me see how many decimal places they want. I might need to zoom out. 2 decimal places. Okay, let me see if I go. I put that here. Okay, that's good. And then zoom out. Okay, I think this will work. It's a little bit temperamental because I'm working on an iPad. So it does throw a tantrum a little bit. Okay, so 2 decimal places, 30.14. Okay. Okay. All right, we got a solid 30 minutes. Let's keep plugging and chugging. All right, generate. Let's go to question 91. And this is about the best I can do as far as getting a good mix of different questions from the whole chapter. We go to question 91, my little RNG or whatever. All right, so this is differentiating an exponential function, right? Because the variable is in the power. So it's just, you treat it just like e, but there is a caveat. We have to multiply by the natural log of the base. I think that's how it goes, right? So if we imagine this was like e to the power of x, right, it would be itself. So we do repeat that part. It should be 34 to the power of t. But then I think we need to say times the natural log of 34, because if that were base e and we multiply by the natural log of e, it would work, right? And then we would be back to what we're used to. When we have an exponential function that's not base e, we say times the natural log of the base, right? So we're going to say times the natural log of 34. Let's cross our fingers. That should be good, right? Okay. And again, if I need to just say it again, just, I know sometimes I probably sound short, but don't worry about that. If you have a question, I'd rather you ask your question than be afraid to ask. I don't want you to be afraid to ask. Just ignore like if I'm irritable. Don't worry about that. Your job is to ask the questions. My job is to answer, right? 58. All right. Let's go to 58. I want you guys to be able to ask questions. And feel confident about asking questions. In 2011, a country's federal receipts, money taken in, totaled 2.45 trillion. In 2013, receipts were 2.64 trillion. Assume that the growth receipts F can be modeled by an exponential function and use 2011 as year 0. Find the growth rate K to 6 decimal places. So it looks like we're solving for R. And write the exponential function. Okay, I'm thinking it's going to be similar to PERT. Estimate the total federal receipts of 2015, and then when will. Okay, I think we're going to need to take some notes for this one. Okay. So this comes from section 2.4, question 15. I think it's business economics. Okay, so let me get a copy of this guy. We're going to take some notes and knock it out. Yeah, like, I don't know, like today was an adventure for real. Like I got stuck in the mud. And so I started researching like ways to get stuck out of the mud. And I tried some new techniques where I think it would have worked. But the difference was in those videos, these guys were like on a flat surface. I was at the bottom of a muddy hill. I was like, this is getting worse and worse. Every time I try, it'll go further and further down the hill, but it wouldn't come back up. So eventually we finally got somebody with the proper tools with like a winch to come out, and once we had the tools, they just pulled it right on out. And so then I was like, well, damn, do I need to just go and invest and get one for myself? Because I was like, I know I could have like anchored to a tree and got it out, but we didn't have a winch, so we just got a guy with the truck that had one. You know. Anyway, okay, so let me see. Exponential growth. I'm going to use like something like PERT. So it's something like the future amount. Come on. It's going to be the starting amount. Let's see. Times e to the kt. I think this. Let me see. Assume the growth can be modeled by, and I think it's. Let me see. It went from 2.45 to 2.64. So it looks like growth. I think exponential growth should be fine. Okay. So they gave us two pieces of information. In 2011, you know, that's going to be our year zero. Again, that's 2011. The money taken in was 2.45 trillion. Trillion. Okay. The second piece of information was what? 2 years later, so 2013. The money taken in was 2.64 trillion. This is in trillions. F base. So we want the federal receipts based on time, right? Okay. So if 2011 is our year zero, that should be our A naught, right? Like if we let T be zero, we're going to have e to the power of zero, which is 1, right? So then A naught equals, right? So if we let 2011 be year zero, then that implies that the starting amount is 2.45 trillion. Okay. So then now with that, we plug that into the second piece of information. So our A naught should be 2.45 times E. We're trying to solve for K, right? Find K to 6 decimal places. Oh, and write an exponential function. Let's keep going. I think we're okay. The time was what, 2 years later? So it's 2K. And we finish with 2.64 trillion. Okay. So then we can divide both sides by 2.45. We're going to get e to the 2k equals 2.64 over 2.45. I just divided both sides by 2.45. Now what I'm going to do is take the, hopefully you're thinking, natural log on both sides. That these cancel, and that allows this to come down. The right-hand side, I'm going to just leave it until the end. So I'm trying to be exact until the end. So now we have 2k equals the natural log 2.64 over 2.45. Okay. And then we divide both sides by 2. So then the rate should be like 1/2 times the natural log of this over this. Now it might be a little off because I think they do kind of crunch some numbers along the way. And I know that does throw things off a bit. So we're gonna do the best that we can. So first I'd like my calculator. Okay, all right. So let's clear. Let's do 1/2 times the natural log of 2.64 over 2.45. Okay. So our growth rate, it says 6 decimal places. All right, moment of truth. All right, let's see. 037345. after the 5 is a 4. 2, 4, 6. Cross our fingers. Woohoo! Right. So we had the right formula and we did it. We applied it the proper way. Estimate the total federal receipts in 2015. Okay, so they're essentially, we can create a model, right? So model, right? So for instance, in general, let me see, the future amount is going to be A naught times E to the KT. So then, here, let me get the model. Starting amount, A naught is 2.45 times E, the rate. There it is. So then our K was 037345. 03. Okay. So now if 2011 is year 0 and we want 2015, that's what, a total of 4 years later. So we're trying to find A of 4 based on this model. So 2.45 E to the 0.037345 times 4. Right? I think we said it was 4 years later. 4. Okay. So now we're ready to use our trusty dusty Rusty. Come on. All right. So I'm just going to put it in manually. 2.45 times E to the power of 0.037345. 0.037345 times 4. Okay. So then we got that result. Okay. Oh, they want the function. Okay, we got the function. We can do it. Zoom out just a little bit. Let me see. 2.45. 2.45 times E to the power of 0.037345 times T, right? That's the function that we used. Okay. And then if we want the amount in 2015, we said let T be 4, and we got a result of 2.84 trillion. That's not a point, 2.84 trillion. 2 decimal places. Cross our fingers. God is good, right? Okay, we got that one. When will the receipts be 7 trillion? So now they're asking us to take our model, set it equal to 7, and then solve for T. Right? So we're going to take our model. So then I guess this is question part C. So we're going to say 2.45 times E to the 0.037345 times T. We want to set all of that equal to 7 and solve. Okay. So first we're going to divide both sides by 2.45. 373.45 T, 7 over 2.45. I'm just going to leave it exact. Then I'm going to take the natural log on both sides. Okay. These cancel. That allows this to come out. So then now on the left-hand side, we have 0373.45 T. On the right, I'm just going to leave that guy as is. If you crunch that number, my recommendation is write out the long decimal all the way. Now, ultimately, T is we divide both sides by that decimal. Natural log 7 over 2.45 over 0373.45. now we just crunch that number. Okay. So let's go like this. I want this. All right, showing signs of life. So let me see. ln is S 7 mash 2.45 2. Shyster. Let's try that again. ln is S 7 mash 2.45. Okay. Parentheses. Mash. Okay. That decimal. 0.037345. Okay. Looks good. Cross our fingers. So we said 28.11 years later. So what I'm going to do is put U right here. I'm going to put U right here. Come on. There you go. Right here. Round to one decimal place. Okay. So 28.1 years after. Okay. We got a solid 15 minutes, if not longer. It's a little bit closer to 30, but I don't really want to keep you longer than 15 minutes. Okay. So let's generate. Okay. This says question 60. So we're going to go ahead and do question 60. That was 58, so that's just 2 questions later. This is another big business economics. The cost of first class postage stamp was 3 cents here and 33 cents there. This increase represents exponential growth. Write the function S for years after 1965. So it looks like 1965 is going to be our year 0. This is a repeat. It's just like with different. I'm gonna leave this one. Let's see. It's multiple choice. 65 is 3 cents. Okay, that's fine. So it looks like it's either A or D. Let me think. What's the difference? KT. For in this case represents. Let me see. So we got our A naught. Let me see. Times E to the KT. So we're probably trying to solve for K. How many years later is that? That's 30, 45 years later. Is that 45 years later? Let me see. We could solve. Okay, just because I feel like it's either A or D since it's multiple choice. I think I'm just going to go. I mean, we can solve for the rate. Let me see. Write the function of the stamp T years after this. It's either A or D. I'm just gonna. I mean, we could write it out just in the interest of time. I'm just gonna go with A. Okay. Because the only reason I didn't choose D because it still had K in there, and I know that we can solve for K. And the reason it's not being C is because they have the wrong A naught. Right, the A naught was supposed to be 3 cents. So that from there I knew it was either A or D, and then D still had K, and I was like, I think we can solve for K. So then that's why I went with A. All right. Okay. So now we have our model. So the growth rate is approximately 5%. I think it's just 5. I got that directly from the model. Okay. The cost of the first class stamp in 2018. Okay, so if 65 is year 0, let me see, 70 will be 30, 48 plus 5, 50, 53 years later. So we need to plug in when T is 53 into that model there. Okay, so we're going to say 3e to the power of 0.05. I think we said 53. This is 53 years later. 42 cents. So yeah, 42 cents. Nearest integer. 42. Let's try 42 cents. Okay. In 2021, so that one we kind of probably should write out, because basically what we're doing is setting that model from A. If the year is 2021, 30, so 70, 30, 50, 56. So, oh, okay, yeah. So we just basically plug in 56 in. Yeah, it's the same thing as that one, just plug in 56. Okay. So instead of 53, we do 56, and we say 49 cents. 49 cents. Okay. Was that it? Nope. 2024. So if that one was 56, this is another 3 years later. So I guess we do 59. So it should be the same thing, but just 59 years later. And 57 cents. Yo, this has to end. It can't keep going up indefinitely. Okay. The firm will save this much by buying stamps at the beginning of 2010. Okay, so if they buy a whole bunch of stamps at 2010, let me see. Okay, this is D. The forever stamp is always valid at first class, weighing 1 ounce or less, regardless of any subsequent increase in first class rate. An Evertime firm spent this on 10,000 first class stamps in 2009, nor will need 10,000 in each year from 2010 to 2025. It decides at the beginning of 2010 to try to save money by spending 3,300 on 10,000 forever stamps, but also buying enough stamps to cover the years 2011 through 2025. Do we have those years? I think we do. Okay, assuming there is postage increase in each of the years in 2018, 21, and 24, the costs predicted in part C, let me see, okay. And let me see to part C, how much money will the firm save by buying the stamps in 2010? Okay. So I think what it is that they're trying to do is buy stamps in 2010 to cover enough to get them to 2025, knowing that the price is going to increase at the years 2018, 2021, and 2024, right? So let me see. 3,300 on 10,000 first class stamps. Let me see. Okay. 10,000, 20, knowing they will need 10,000 stamps each year from 2010 to 2025. Okay. So if they're buying 10,000 stamps each year, how many years is that? 15 years? Okay. How much is it costing? Let me see. At the beginning of 2010, if they just buy 15 sets of their 3,300, we can just say 15 times 3,300, and that's how much they're going to pay in 2010, right? So let's do 15 times 3,300. Okay. So in 2010, they're paying 49,500 versus like now we're going to just go through and manually count each year, right? So let me see. Okay. So if they just bought all the stamps in 2010, it should cost them 49,500. So now the first increase looks like it happened in 2018. So from 2010 to like 2017, that's what, 7 years? So then we're going to say 3,300 times 7 years plus, now we have an increase from 18 to 20. That's what, 3 more years? And it costs whatever answer we got. No. How much is that going to cost them for 10,000 stamps? That's a lot. So let me see. 42 cents per stamp. Okay. So now for each year we're doing a total of 3 years, right? We're going to say 3 times. And for each of those years, we want 10,000 stamps at 42 cents a stamp. So what we're doing, 42 cents times 10,000. Let me see. How many times are we moving it? 4 times, 1, 2, 3, 4, 4,200. Okay, so I think it's 3 times 4,200. I'm just trying to get you guys out of here. Plus, now we're going from 2021 to 2023. I think that's an additional 3 years. So we're going to say 3 times. And then in 2021, it was 49. So I think it's going to be 4,900. Okay. That gets us to 2023. And then we got 2 years because we got 2024 and 2025. So we're going to say plus 2 times 5,700. Okay. Now, so if they just bought it each year, the first 7 years is 3,300 for each year. The next 3 years is 4,200 each year. The next 3 years after that is 4,900 each year. And then the final 2 years is 5,700 each year. This total comes up to 61,800, right? So now how much are they saving? We're going to say that larger number minus the smaller number. This makes sense. Making sense and being correct are not always the same, right? So let's see what happens. So it looks like if they just buy the forever stamps to cover through 2025, they can save $12,300, right? Let's see. That's reasonable. That makes sense. 12,300. Let's cross our fingers. 12, because if that's not right, then I don't know. God is good, right? So that one was business economics. Like the first set of parts A through C, I mean, it wasn't too terribly bad. We'll do a quick recap. Let me see. So again, for part A, part A was similar to how we did the previous example. So that's why I didn't really want to do it. And then when I saw it was multiple choice, I was like, okay, well, I knew that in 65, with that being year 0, that means my A naught or S naught, my starting amount, was 3 cents. So in 1965, it cost 3 cents, right? That was my starting amount. So with that information, I was able to knock off B and C, right? So I knew it had to be either A or D. And then, we had at least 2 pieces of information, so we could solve for K, right? D still had K in there. And I was like, no, I think we can solve for K. So if I had to choose between A and D, I went with A. Now, otherwise, I could have just worked it out like I did the previous one, and eventually we would have got to this result. So then once we had our model, then we were just using the model. What was the growth rate in the cost, right? And so that 5%, I just pulled it straight from the model, right? A naught E to the KT. The K is 0.05. The decimal 0.05 means 5%. So I just pulled that straight from the model. The cost of a first class postage stamp in 2018. So then I think this is the growth of it. 2018, I think, we had to figure out how many years later that was. So it was like 30, 48 plus 5 was like 50. It was 53 years later, right? If time equals 0 was 1965, 2018 was 53 years later. So all we did was plug 53 into the model. We got an answer. We got 42 cents. And then for 2021 was 3 years later. So we plugged in 56, meaning 56 years later, we got an answer. And then 2024 was another 3 years later. So we plugged in 59 years later. And it gave us a price of 57 cents. And then the last one, so they're trying to see how much money if they save if they buy these forever stamps that don't increase in price. So if they bought all their stamps to go from 2010 to 2025, that's a total of 15 years. And they know that they needed 10,000 stamps each year. So 10,000 stamps cost 3,300. So then it was a total of 15 times 33. We got our answer of whatever it was, right? We got it over here, right? We knew the amount it cost for each year times 15 years. Then to figure out how much they're saving, we had to break it up into parts. We realized that the first 7 years was the lower rate of the 33 cent, the 3,300. And then starting in the year 2018, for the next 3 years, it cost it costs 4,200, right? 10,000 times 42 cents to give us 4,200 for each year. And then the next set of 3 years was 4,900, and the final 2 years, right, was 5,700, right? For something like that, it might be easier if you just make a table, right? And like if you had the year versus the cost of 10,000 stamps, right? And that you might be able to see it that way as well. So then once we got that number, we said the larger number minus the smaller number to get the difference. Okay, gentlemen. I know that one was a bit a doozy, but and that one was really just reading the model. All right. Once we had the model, then it did take a little bit of grit, a little bit of back and forth to kind of sift through it, but you experienced it. So again, these assignments are just for practice. Just do the best you can. The final is everything from beginning to end. So chapter 1 through chapter. Not this Sunday, but a week from this Sunday. Once you get access to it, you get unlimited attempts for 5 days. Right. So just do the best you can. Take notes. You get a score. If you want higher, try it again. Right? You have nothing to lose and everything to gain by trying again. Until you don't want to try anymore. Let's go traditional, calculus, notes, daily. Do I have the one from last time in there? I do. And here's the next one. So just pretty much now you'll have a copy of anything that you saw me writing. And then so we only have 2 meetings left, right? We're going to meet on Monday and Wednesday of next week. Next Wednesday is our last time being live. And we'll review chapters 3 and 4. Are there any burning questions for me before we go our separate ways? I intend to I'll do grade updates. I'll update the grade probably on next Wednesday, the last class. Like if I haven't updated it by next Wednesday, then I'll just take time during class to go ahead and update the grades. And we'll try to make sure that everybody's on the same accord. And if you joined us late, if you're going back to like do old assignments to boost your overall grade, my recommendation, get your exams in order first. That's where you're going to get the most bang for your buck. Those have the heaviest weight. And then prioritize the homework last, because the homework is a lot of work for minimal points. All right, so that's the order of priority. Okay, so if there aren't any burning questions, we're going to go ahead and end the session here. From one beautiful mind to another. Have a great weekend, guys. Study hard and play hard, right? So work hard, but then try to get some rest. If you want something, now I don't think this event is free, but I don't think it's that expensive either. It may or may not be free. And I don't think it's this Friday, not this Friday, but next Friday at the High Museum of Arts is like their first Fridays. So it's like basically, with admission, you can tour the museum. It's just an art museum, but it has like live music. So it's just something that's fun to do. But then if you do want something that's free, the second Sunday of every month. So I think that's that's 2 weeks from this Sunday. Is free admission at the High Museum. So the second Sunday of every month is free admission at the High. And it's just something that's free to do. You can park next to the High on Sundays during that time for free. So it is more free on that second Sunday. If you come at another time, you're going to have to pay for parking or walk or whatever. All right, gentlemen, have a great weekend. Good luck. And I'm available if you need me. Send me an email and use my office phone to get my attention so I can be on the lookout for it. Otherwise, have a great weekend, and I'll see you next week, same time, same place. Take care. Peace.